deeply honored of receiving this great opportunity for welcoming our alumni for today, Mr. Aniket Chaudhary. It gives me immense pleasure to address you all on this occasion of our Mechanical Engineering Department's Alumni Speak series. A day like today is very important for us as it provides us the opportunity to meet with many of our graduate students after a long time. Today, in Alumni Speak series, we are presenting our second speaker, Mr. Aniket Chaudhary. Today's topic of presentation is exploration of career opportunities for mechanical engineers in the world of automobile engineering. Now, I introduce everyone with today's speaker, Mr. Aniket Chaudhary. Mr. Aniket Chaudhary completed his bachelor's degree in mechanical engineering from Rajiv Gandhi Institute of Technology in the year 2010. His most profound memory at RGIT is to represent the college as a team captain of Team RGIT Formula SAE 2000 team in FSA Italy competition at Parma, Italy. For 1 year after completing his bachelor's degree, he worked at Orbit Technology Private Limited as a senior engineer from July 2010 to May 2011, where he received an opportunity to work on designing both linear metallic components, that is structural components, as well as non-linear rubber components, that is automobile engine bush. It involved developing CAD models, performing FE analysis to validate with the test results and to understand the failure modes. Thereafter, Mr. Aniket Chaudhary completed his master's degree in manufacturing engineering from Indian Institute of Technology, Bombay, with specialization in CAD and CAM. He worked as research assistant in CAM lab during his tenure of MTech at IITB. After MTech from IITB, Mr. Aniket Chaudhary was working with Rolls-Royce for a period of 5 years. Out of these first 2 years, he was part of Rolls-Royce Global Graduate Scheme and worked as a manufacturing graduate at various sites in India and in UK. While for the next 3 years, he worked as an advanced manufacturing engineer at Rolls-Royce India Bangalore office. These 5 years gave him exposure to the various activities of manufacturing engineer, such as CNC programming for machining of titanium and nickel-based disc-type components on single and twin turret blades, tooling design of folding devices and lifters, as well as external supply chain related activity. Recently, Mr. Aniket Chaudhary joined as Research and Development Engineer at National Manufacturing Institute, Scotland, Glasgow, from the month of June 2020. Now, I request Mr. Aniket Chaudhary to start the webinar. Over to Mr. Aniket.
Thank you, Professor. Let me start by sharing my screen first, so that will be good. Okay. So, good morning, my dear friends. Good morning, all the professors. Thank you for giving this opportunity to present a webinar like this. It is an exciting opportunity for me. Firstly, let me introduce myself a bit. I'm Aniket Chaudhary. As Professor Londekar said, that I'm alumni of 2010 batch, and I've completed my bachelor's from RGIT from our college. I was asked by Professor Bokade sir, who was at my project guide in 2010, that can I give a small, a session over here, allow the young students to see and explore the world of automotive engineering from a mechanical engineer's perspective, and that was an awesome opportunity. Apart from this, there were two hidden intentions of mine to give this presentation. First one of them was to give all of you guys a small methodological way of how to develop your career, something which I tried and I'm still using it today. I've been successful in using that. Probably you can try that out. If it works for you, then great. And second one is to inspire at least a few of you guys to probably work in the field of automotive engineering or aerospace engineering. So yeah, let's start off. Firstly, about myself, most of these things have been covered in my presentation by Londekar sir. So I'll just touch base on few of the things. uh, Firstly, during my tenure in RGIT, I was the most memorable memory that I have is a formula student competition in Italy. And the entire team even today fondly remembers it. I think Bokade sir was also there, and he will vouch for it as well. So it was really one of those awesome experiences in life that we live up to. And even on today, on my and my teammates, who are my friends and colleagues, uh, consider this to be one of the important points on our resumes. So after that, another thing about masters. So masters from IIT Bombay was the first stepping stone towards research. It introduced me to research, how to go about in the field of research. So that's about education. Work experience wise, I have about 6 to 7 years of experience as of today. uh, I just joined a new job in June 2020. So I started this month itself in National Manufacturing Institute, Scotland. So probably I can say I'm one of the proud people to have gotten a new job even during a COVID situation. So yeah, nothing is impossible, guys. You can do it. Before this, I was working with prestigious Rolls Royce. A word of caution here: when I say Rolls Royce, it's not the automotive company. Automotive company Rolls Royce is basically owned by BMW, and they produce car on our behalf, that is Rolls Royce behalf, and we pay and we get the royalty out of it. When we say Rolls Royce, it is an aerospace industry, more or less. It is power systems and aerospace, to be honest. uh, we make all the engines for most of the long body aircraft, such as example would be Boeing A380, or sorry, Airbus A380 or Boeing 777s. So most of those engines are produced by Rolls Royce. Before that, I had a work experience of 1 year with a small firm which was started off by few of my friends. That's Orbit Technology. Is still active today, and we have very strong number of engineers working over there as well. Even today, I have very much in contact with all of those guys. Interesting thing on my resume: I started off as a design engineer into automotive industry, be it then FSAE, be it Orbit Technology. Moved on to more into aerospace and manufacturing background to today, which is more or less R&D in manufacturing. So that's a bit about myself. And yeah, let's start off with our presentation then. Firstly, when you say automotive manufacturers or the world of automotive engineering, there are two types of players in this entire world of automotive. First are mass producers, second are niche players. So when I say mass producers, the thing that should come to mind is uh, something like companies which have big production lines. They produce about thousands of cars together, thousands or lakhs of cars together, one after another. For this type of industry, time is money. If 1 hour of delay that's caused to any of these companies, it will be X amount of losses to the company. So generally, time is money in this case. And the life changes in terms of cars is very, after a long span of time, and it varies to an entire engine to an entire car family. For example, let's take an example of something like a Maruti Swift. When a Maruti Swift gets a facelift or something like that, it's not just the Swift that gets changed. You can see the changes being cascade to Desire, to Baleno, to most of the other Maruti products as well. So mass producers are ones which earn their profit in by this means, because they have interreplaceable parts in many of the cars that they sell, and that's where the volume games come into picture. You get more profits out of these things. On the other hand, you have niche players. Niche players, when I say, it's like Ferraris, Lamborghinis, Bugattis, Koenigseggs. Most of these cars are handmade even today. An example of this is, if you look at Mercedes, they have a small division called as AMG division, which is into more into sports cars and those type of stuff. And this even today, the each engine of AMG is produced handmade, and there is a small amount of a margin where each engine that they produce is different from the another one. The performance that you get is slightly different in each case. That's because all of them are handmade and it is signed off by an engineer on the top of the hood. So that's the niche players. This thing, for them technology is money. New technology is what makes their cars sell. Each car, if you look at any Ferrari, Lamborghini, McLarens, will always look into what is the new technology. So that's where their ball game is. And for them it's more about this modification of technology per car basis. If you look at Lamborghini Gallardo versus Huracan, the changes that have happened in this is just to these two models. So when there is a phase change, it is between these two models. It's not over a product family. Yes, there are small things that are carried forward onto the other cars as well, but the major changes is within a given product to product basis. An interesting thing about these niche players is that these players are much more nearer to aerospace, because if you look at somebody like Rolls-Royce or Boeing, Airbus, they quite have the same strategy. Technology plays an important game. The changes are per model basis, and they have a small production line as well. So many things between the niche players and the aerospace is quite similar. So yeah, a complete difference in background between mass producers and niche players. So that's something we should remember while moving ahead. Next, let's look at evolution of automobiles. So back in 2010, when I completed my bachelor's, everything was gasoline. So we had combustion engine, and at that time when we said that electrical hybrid was the thing of the future. Today in 2010, about 10 years now, you see electrical vehicles being quite common. May not be in India yet, but if you go to foreign countries, you'll see that electrical is almost 50% selling as compared to gasoline engines. Hybrid is also has its own share with electrical as well. And probably today, if somebody asks me what is the future, I would say autonomous cars and flying cars. So that would be future. Autonomous cars, as many of you might know, there are already people who are trying that out, where a driver just sits back and let the car do its own driving, while you can work, you can have a video call, or just sleep basically. So that's autonomous vehicles. And flying car is something which might see a lot of momentum gaining. So there was one of the projects that is being carried out is by Uber wants to have flying taxis. I'll give a small example of this over here. So if you look at Bangalore Airport is about 1 hour's drive from Bangalore. It's outside of Bangalore city. And if you want to go from the farthest end of Bangalore to the airport, it takes about 3 to 4 hours drive depending on traffic. So if I want to take a flight which is 2 hours to Mumbai, I want to drive 4 hours, which doesn't make sense at all. With this in view, Uber wanted to have something which would be a smaller version of a helicopter, much safer version of an helicopter, which can act as a taxi. So I can take a taxi, like an air taxi or a flying taxi, get to the airport in an hour or so, and then probably board my flight. So that is, I would say, something which is currently going on many of the automotive industries, or many, even for that matter, aerospace industries. They're also having a look at it. An important thing on this slide that I'm presenting right now is that if you look at on the right hand side, I've given a bit of a job description. As the technology changes, the job description also goes on changing. The thing is, the world is evolving and it is not fading out. So that's an important crux from this slide. People will have, like all of us will have to in future change our nature, we should adapt to the changes and move into the next direction that's coming in future to us. So with that in view, let's look at a general structure of automotive industries. Mind you, this is quite a similar structure if you go to an aerospace industry as well. More or less the base structure remains same. Depending on each company, there will be much more modifications to the amount of teams that they will have and what type of teams they have, depending on what are the projects that have been carried out. But yeah, on large and more basis, this industry can be divided into design and manufacturing. When I say design, what does all come into picture? We have something like structural engineering, where chassis, suspension, and drivetrain, all those things come into picture, body, etc. Combustion engine, that includes engine technology, exhaust emissions, and so on. The latest being electrical drive, which includes electric motors, controls, battery technology, and so on. And then if you look at manufacturing, then you have process and technology. dedicated technology towards manufacturing next level processes. Then you have something like shop floor management, where you are looking after the shop floor. More or less, you want X amount of parts to be coming out of shop floor, and you have to deliver to that. You have supply chain management, and you have quality. So I'll take you through each of them. So let's see for the design team first. The purpose of this slide mainly is to understand, if I take one of these technologies, what exactly I'm going to face and what I need to learn. So design engineering, if you look at, these are the four main pictures that we'll see. There are few other small teams as well, but these are the four main crux of design team if you go to any automotive aerospace industry. So first is structural design. So as I mentioned in earlier slide, when you say structural design, it's all to do with your suspensions, chassis, outer body, and so on and so forth. Things that will touch base upon, or subjects that will touch base upon, would be kinematics, dynamics, dom, structural engineering, material knowledge, and FE analysis. FE analysis, when I say, it's more to do with structural analysis, that's static as well dynamic. So you are looking at ANSYS, Abacus, LS Dyna for crash testing, and so on. More into when you say structure, it's more into structures, materials, understanding what's best material to utilize, what is the future material to be utilized, and so on. Next team is combustion engineering. So when you say combustion engineering, is completely IC engines. That probably also would include hydrogen engines as well. So more of the things that you work on would be thermodynamics, aerodynamics. That is basically to design an engine, you require that as a base qualification. Apart from that, you'll require a knowledge of fluid mechanics. That's mainly to do with the flow of air fuel mixture into the engine and exhaust gas coming out of the engine. Next would be chemistry, because if you look at Bharat Stage 6, for example, the biggest change is the chemical composition that's coming out of your exhaust. And how do you remove certain gases or reduce certain gases? That's where chemistry, along with fluid dynamics and other things, comes into picture. And basically, you'll be working a lot on CFD analysis. CFD is quite different than FE. Mainly, it's a volumes game than anything else. So CFD analysis is what you will be more working into. All your Navier-Stokes equations and all those things will come into picture over here, man. So the next one is electrical drive. Electric drive is very new field, I would say. So something that you'll touch base upon is electronics or basis of electrical circuits and all those things. So that's where circuit design, control systems come into picture. A lot of material knowledge, because as I said, this field of electrical drive is still evolving. So we have not yet, we are just skimmed the top surface. So we are yet to decide which is the best material to be utilized, which is the best technology to be utilized, especially in terms of battery technology. So if you look at batteries, as of now, we are still experimenting on different variety of batteries, different materials for batteries, and which is the best composition in terms of getting the most power out of it and being environmentally safe as well. And as the same thing, battery, when it works, it heats up, so you require cooling circuit as well. So all this comes into drive, electrical drive. And last part, this is another important part, what I can say, the whole vehicle integration. So that includes drivetrain as well as whole vehicle, how the remaining three parts fit into a vehicle. What you will be more working into or looking into would be a holistic approach here: gear designing, mechanism designing, how different things sit with one another. Obviously, material knowledge plays a lot of different part, because uh, lighter the material, better the car. It will be much better for working different things around it. At the same time, it should be safe, it should be strong. And when this happens, as there are a lot of mechanisms, there are a lot of gears, you will have to look into fluids as well as cooling. So when I say fluids, it's more into aerodynamics, and when I say cooling, it's to do with removing the heat out of a drivetrain or battery or those things, how you can dissipate the heat in a efficient way. A good example of this is something like high-end sports cars or Formula One circuits, where they use the cool and the dry, the hot air to give a large amount of downforce to improve efficiency, and that's where all these things come into picture. Remember, the landscape of, as I said earlier, the landscape of automotive is changing. By hindsight, if tomorrow, let's foresay that everything is electrical, the combustion engine people will not go out of market. they will come and help people like for electrical drive and drivetrain, because aerodynamics, heat dissipation is still one of the main aspects of the cars even today, whether it's electrical or any other thing. You will convert heat, some energy into heat, and you'll have to dissipate out. So the things won't die, it will evolve, and we have to make the changes in ourselves to this evolution. Next is manufacturing thing. So this is my core base as of today, I would say. So probably I can give much more knowledge on this than the other part. When you say manufacturing engineer, is four main teams that comes into picture would be the process technology, shop floor management, supply chain management, and quality. When I say process technology, it is to do with the basics of manufacturing. What is the next level technology that I can utilize to manufacture the components? Could it be new materials? Could it be new technology? For example, additive layer, additive layer or additive manufacturing. Up till now, most of the things that we have seen were made up of either CNC machining, so that's removal of material, that's negation of material, or forging forming, which is shaping of metal, and so on. Something that is coming up new in this market is additive layer. So you basically deposit material and build stock on top of it. It has its own challenges. It is yet in a proving stage for metals. I mean, you can do with metals, but getting the right amount of microstructure is a very key, and still a large amount of research topic goes on those front. So that's where the material knowledge comes into picture, the process knowledge comes into picture, process modeling, because ultimately you need to model each and every process into a mathematical equation, and that's when you know the entire process. And all these things comes as a process engineer. That's where I am working into, and that's where my new job is more into. That's R&D in manufacturing, as we call it. Shop floor management. Shop floor management in one single line is basically, I need to have X amount of products coming out of my shop floor at the end of the day. That's all. So this involves everything, from cell planning to assembly planning to looking into things like day-to-day shop issues. Might be some machine broken down, might be some CNC or CMM machine having some issues, and you need to go there and solve those issues and all those things. End of the day, all you are responsible for is the amount of products that are coming out from your plant or your cell. So that's where shop floor management comes into picture. Next, similarly, we have supply chain management. If you look at most of the aerospace or automotive companies as of today, 40 to 50% are in-house. The remaining 50 to 60% is outsourced. Managing this lot of outsourcing is what supply chain engineer does. For him, the most important thing is when a product comes into our own company, we need to ensure that it has right quality, it is made up of right process, and it will do the job. That's the most important thing. It adheres to all the things that are given by your government that you are working along. So all of this is what a supply engineer does. He looks at supplier development, making them develop their own processes, which benefits not only those people but us as a company as well. Looking at quality of the products that are coming out, looking at the process as a whole, and at the end of the day, managing the delivery and the cost, because cost is something that always drives these supply chain activities. So all these things is where supply chain engineer comes into picture. And last but not the least is quality. Quality, when I say, it's more into inspection. So that includes inspection planning, inspection methods. You require a strong material knowledge, because once you know a material, how it behaves, that's only when you can inspect it. So for example, if you do a machining, if you remove the forces, there will be spring back. So whether a material has to be, a given product has to be measured in a constraint strain or a non-constraint strain is something what a quality engineer will be deciding. And a lot of problem skills, I mean, problem skills is required in all of this, but quality engineer has to be on the toes, because if something goes wrong on shop, the first call that goes to is the quality manager. He has to come down and decide what is the next course of action, whether you have to quarantine a part, whether you have to stop something, or what exactly should be the next stage. Remember, if you stop a production line, it's X amount of losses to the company. So it's not an easy thing to do. So that's where problem solving skills come a lot in this picture. So this is how a manufacturing team looks like. Next, something of a big different topic, I would say. This is where there are two school of thoughts of career choices. First is subject matter expert, second is business management. So if you look at the earlier slide on manufacturing, there are two things that I can go into subject matter expert, that is process technology and quality. While two things that is more into management side, that is shop floor management and supply chain management. So what is subject matter expert, or SME as we like to call it? An SME is a guy who is more involved in a given process. He goes to the depth of the process and try to understand what is the next technology that we can utilize. He has to have a bit of a knowledge on the breadth level. So I, as a CNC expert, I need to know about forging, forming, and other things. But my main focus is what's next in CNC technology. If you go on this career path, over a period of time, things that will come across is doing a master's, doing a PhD, or doing a fellowship somewhere. So subject matter is going more into the depth of a given subject. Business management at the other end is more of a people oriented or administrative oriented jobs. So as I said, shop floor management, so managing an entire shop floor or a given cell, or managing a supplier, be it a small supplier, big supplier, something like that. Here you need to have more depth. You should know quite a few depth amount of skills rather than having a more amount of breadth as compared to depth. So I need to know something a bit about forging, bit about forming, bit about CNC, bit about inspection. I did not have to be going in depth of any of it. If I have a problem, I can always go to an SME and sought his help. But I should know as a business manager what is my next step. That's where the things comes into picture. If you follow this career approach, probably you might land into an MBA, PGDMS courses, or probably a master's in operation research. Many people have a thought that you can earn more money if you are a manager. Well, that's not completely true. Uh, in many cases, for example, if you especially look at niche companies, as we said, Ferraris, Lamborghinis, or Rolls Royce for that matter in aerospace, subject matter has a lot of value, because when a subject matter expert leaves a company, he takes a chunk of big knowledge along with him. And if he goes to a competitor, oh my god, please help that company, because he has all the technology he has taken, he has worked on, he has taken it completely to a new, to your competitor. So it is like a difficult situation. And to retain such an engineer, companies pay a lot of money as equivalent to a CEO for that matter at times. So it's not that subject matter doesn't earn a lot. It's gradual, but he can earn a lot. So cost should not be a driving factor for this. So this is all the career opportunities. So what I've shown you, the different, as of now, is the different things that you can look into as a automotive industry, and what are the career choices that you have. Next slide is a quite interesting slide, because I'm going to show you a live example of careers in Ferrari. So this is the current website of Ferrari. Let me see if I think I'll have to share this as well. So yep. Yeah. So right now, what you are watching is a Ferrari website. So corporate.ferrari.com. This is a Ferrari website. These are the career opportunities that are there. So what I picked just now: manufacturing engineer, electronics engineer, component design, engine development. All these are what we were just saying. Buyer, if you look at, say, buyer, this is nothing but supply chain management, plant management, shop floor management. So exactly, so what we said right now is what you can see over here. If you, let's say, click on one of this, it will open a small field for you where you can apply, and there is a bit of description of what exactly this job requires and what it is that you will gain out of this. So probably something which you can in your free time have a look into. Just Ferrari is one of them. You can go to all the big ones like Lamborghinis and probably McLaren and all, and see what are the upcoming job that they have, and what is the progress that each job goes into. This will also help you, mind you, for developing your own career. So let's go back to our slides. Yeah. So now I'm into the second part of my presentation, where I said I had some hidden motives. Yeah, so that's where the hidden motive starts now. So I want to give you a methodological way. We are engineers, so we always do things by methodology. So I want to give a methodological way of how to develop a career. This is something which I tried on my own, and it has worked for me. I cannot guarantee it might work for all, but it's worth a try, I would say. So first thing, when you what I like to call this approach is called as career story. It is like any other story that you read. If you are writing an essay, how do you think about what exactly should I write? It's the same thing about career. What exactly I want to do in my life. First thing first, let's start off with basics. Each person has his own story. Each one has his own pace of achieving this story. If today I am, so my, for example, my story, you cannot say that I want to do exactly what Aniket does. No, it's not possible. You cannot do what your friends do. Each one, as I said, will have his own story, and each one will achieve this at his own pace. So that's a crux of to remember when you start with a career story. So what do you want to do? Okay, so let's first thing first, you need to have an end goal. For example, I'll give my own example. So long back in 2010, when I completed my bachelor's, I was similarly looking into different websites. Ferrari was one of them, one of my dream companies, I would always say. So I looked at Ferrari website and I saw an opening of chief technical engineer. So that was my end goal. I wanted to become a chief technical engineer in Ferrari. I got my things sorted. So I wanted to go to automotive engineering. I wanted to go into technicals. I wanted to become a chief engineer. Okay. So, okay, how do I become a chief engineer? That's where I decided to have a plan. I started chopping down from the same website. I could understand what I require to become a chief engineer, and looking at my current set, what I need to do to reach that goal. So for example, people would say, you need to learn this software, that software, you should have knowledge of this, you should have experience of that. So chalk a plan of how you will get, how will you learn different software, how will you get different uh, experiences in life. Could be some small working or some internships, could be some research organization that you can work with, and all those things. So then the next part comes is to review this chart on time to time basis. So like every 6 months probably, or 4 months, as you wish, have a look at this your own career plan path, and think about where I am, what I need to do this. Beware, there will be modifications, and it's okay. There are times when even your goal post changes. For example, in my case, I wanted to become a chief technical engineer in Ferrari. Today I am more into looking into becoming probably a team lead in a manufacturing firm or a manufacturing R&D institute. So a goal post may change, and that is completely okay. The thing is, when your goal post changes, you need to direct your plan according to the new goal post. It is same thing as saying that in a given cricket match, if rain falls and you have to go with duckworth Lewis, your goal post has changed. You need to think on the spot and see what's the next approach I need to take, whether I need to slog the overs or what exactly I should do. So it's the same thing with your career. If your goal post changes, you have to make modifications. Remember, at this point, learning never goes waste. So for example, somebody asked me, today I am a manufacturing engineer, so what I did as a design engineer, is it waste? I would definitely say no, because being a manufacturing engineer with a design experience, I know exactly what a designer requires, and I can utilize this experience of mine to make a better technology without anybody's help. So you should know how to cash in on your learnings, and not just say that it's a waste of learning. But learning is never wasted. It's how you use it that matters. Make these keynotes, jot these key points in your life, and join the dots. That's where you will end up with after joining the dots. That's what matters. There will be always hindrances in life when you do all these things, and overcoming is the best part of it. That's where you get confidence. That's where you realize what you can achieve, what you cannot achieve. And last but not last, two things I want to say. First is hard work. Be a round Dravid in life. You should do a lot of hard work, and make things happen. Nobody's there to help you out, so you have to make your own things. My building blocks, this is my building blocks, I would say. So if you look at FSE experiment, strong fundamentals comes from RGIT, FSE, then coding skills, research methodology in my IITs, and the rest comes from the industry experience. With all this, today I've end up over here, which is an R&D firm sponsored by Scottish government, and Rolls-Royce, my ex-company, is a tier 1 sponsor. So this is my story. Probably you should see what's yours. Career highlight of mine, leftmost is FSC, RGIT, FSC. You can see Bokade sir over there. In middle part, it is IIT degree, my MTech project, life in IIT, and right hand side is all about Rolls-Royce and industry experience that I've come across. With this, I'll end my presentation. Before ending, special thanks to RGIT College. It is always a privilege to come back to college. Thanks to Bokade sir, Londekar sir, and all other professors. I didn't put others' name. I didn't know who are attending. So sorry for that. But thanks a lot for all my professors. Technical committee, thanks a lot. And lastly, to all of you guys who have been patiently listening to my presentation. Thanks all guys. That's it from my side. Thank you. Any questions if there are any? Yeah, that's it from my side.
Thank you, Aniket.
Thank you.
Nice and informative webinar by Mr. Aniket Chaudhary. He explained us in detail about different teams, that is design team, manufacturing team in automobile engineering. Hidden motives for different career choices and opportunity for mechanical engineers in automobile sector, and which skill sets to be updated to grab the dream job in today's competitive world. Now, some students participants are eager to ask you a few questions. Hence, I'm requesting technical team to connect with them. First, I want or request to technical team to connect with Rishikesh Matre. Rishikesh, are you there?
Yes, sir.
Okay, ask the question.
Hi, Aniket. Really amazing lecture that you had. And I just had one question, which is on the overall state of the designing industry, considering EVs, the widespread adoption of EVs that we have now. And that is that considering the negative impact of the COVID-19 crisis, do you see car manufacturers cutting down on the native EV platform development and focusing on internal combustion engine conversions instead?
Good morning, Rishikesh. Thanks
Hi.
for your comment. Well, as I understand, you are more worried about COVID situation creating problems for EVs.
Yes.
I don't think so. That should be a worrying factor, to be honest. So, if you
Okay.
look at one thing, remember, technology always evolves, whatever happens. So, no company would backdraw on technology. They do not want their competitors to move ahead of them. So, the technology doesn't drop. In fact, if you look at my own thing, I didn't expect a career job change in R&D in a situation like a COVID. But yeah, it's happening today, right? So, jobs will not go, technology will not stop. If at all, it will evolve probably at a slower state.
I see.
And talking about EVs, as of today, yes, they are the future. Rather, they are the present right now. So
Correct.
I see engine is not going down, but EVs are coming up. So it's more about you evolving towards new technology. As I said, so if you are a thermal engineer, for example, you will not go jobless. You will be converting your knowledge into something like a cooling engineer, or probably into something like aerodynamic. So you will become
Right.
aerodynamist or something like that. So it's about evolution rather than totally saying, okay, I'll go jobless. So
Okay.
hope I answered your question.
Yes. Thank you.
Yep.
Now I request technical team to connect with another student participant, Javed Khan.
Hello, sir.
Hi, Javed. Good morning.
Good morning, sir. What my question is that I would like to ask you is, now, as we are well aware that EVs are the future and autonomous cars are coming into picture, as you clearly mentioned that EVs are already present, but looking at the Indian scenario, the kind of people or the kind of economy we have in the country is that people cannot afford, costly cars. So the range of EVs start from somewhere around 30 to 40 lakhs. So how will it be feasible for the for a person, for an engineer, to make the cost down and make EVs accessible and at a low budget for the Indian economy? How will that be possible? Yeah.
Okay, so as I understand, you are worried about the cost driven by EVs. Good news for you is that Tata has already started that progress on that. So you have quite a few cars like Tigor and all who are in slowly coming to. So I remember Nexon and Tigor are two cars that have come up into the market right now, which are cost effective. Probably you'll have to pay a lakh more than what you get for a normal Tigor, and you can still buy one of them. As I said, the problem is always with battery technology as of today. So I would not be comfortable taking one of the EVs to move from, let's say, Bangalore to Mumbai for matter, because I don't have a charging points. However, government has made a lot of programs and progresses and thoughts about building up EVs, and many companies are holding hands with them, be it Mahindra, be it Tata. So they are the two major giants in India, what we have, and they're doing it. Tesla is going to launch very soon in India. Had it not been COVID, probably we would have heard the news by now. So with that all things coming into market, probably let's say in few years, it would be much more easier for us to take EVs outside as well. But so the world is evolving. If you say about mobile phones, few years back we would not have bought a high.
Again, I request technical team to connect with our last student participant, Satyam Kaul.
Hello, sir. It was a very informative lecture.
Hi, Satyam.
So
Good morning.
I only have just one question. What are your thoughts about the car sharing and renting of through different platforms like Ola and Uber? Wouldn't it lead to a decrease in the individual car production, as people are starting to prefer more taxis and different stuff?
In that case, I would say COVID has helped us a lot, because now people would be more bound to have their own car than share a car. So yeah.
That is true.
But yeah, looking at other way around of the scenario, if the market for personal cars goes down, there is always a chance that the market for the hired cars go up. So if I am a consumer who wants to go by Uber instead of my own personal car, I would still expect same amount of luxury. So if I'm not buying something like a City, I would expect Honda City to be in market where I can book by Uber. So if one thing goes down, the other comes up. That's one. Second is, if you look at many companies like Hyundai or even Maruti is thinking for that matter to have something of a different strategy. So you don't own the car. The company owns the car, but you pay, it's like lease license. So you lease a car out of Hyundai directly instead of some leasing company. Over a period of 10 years, you can keep on paying them some amount of money. At the end of 10 years, you can think about whether you want to buy the rest of the car completely or move on to a new car from Hyundai or Maruti or whoever it may. That is something many of the companies are thinking about, leasing. Few of these are already in UK. What I remember when I've been in UK, I've already seen few of these done with Mercedes and all. It's more like a lease license. So the car is still owned by the company themselves, but you are the rightful owner in equal percentage. So companies are evolving in that strategy as well. So yeah. So the point is, at the end of the day, it will not go down. Probably it will come to a standstill. But new technologies always evolve. So yeah.
Thank you, sir.
Thank you.
Good morning, Bokade sir.
Good morning, sir. Good morning. Good morning, Aniket.
Good morning, sir.
Please continue with your session. Towards the end, I will speak then.
Okay, sure.
Okay.
If there is any more questions.
There's no question afterwards. I hope all the participants are satisfied, happy, and optimistic.
Aniket.
Yes, sir. Yes, sir.
I have to say one thing. What you would like to say to your SAE team? SAE team. RGIT SAE team.
RGIT SAE team. Come on, guys. Only one thing I need to say is that, win some competitions now. It's high time. But on a serious note, keep up the good work. Remember, evolution is the key. You need to evolve. Every card you make, you should do some evolution. That's where you'll be in the game. If you are lacking that, you'll be moving backwards. So evolve to the new technology, understand the new technology. I heard they are moving into EV sector, so that is something interesting. New technology opportunities. So yes, go ahead, guys. We are always there to help you out. All of us FEC guys are always there at a click away.
Asha, are they in touch with you?
Yes.
Every time they contacted.
Yes, the picture that you saw over there of all my team, including Bokade sir, everybody's in touch.
Okay.
Yeah, I think question answers are done now.
Yes, sir.
Yes, Aniket, I trust you are well with your family members at your place, right? And I felt very happy to see you today talking to the students. And you are one among our proud alumni. We feel proud of you. And you were the first team to take the SAE car abroad. And you did extremely well there. So, I always believe that efforts has got more meaning than the result. And as I was accompanying your team, because I too have a lot of memories of our Italy visit. And as I was accompanying, what I've seen in general, which was very appreciable, was one common understanding between the whole team that you have to go and you have to compete. And that was the reason that the team was always intact and you could do it. And thereafter, even I am being reported by the SAE boys that they keep in touch with you and the SAE team members of that kind. And that is really great that alumni interaction should happen so positively. And you are in touch with us. It's not a long time that we didn't speak to each other. So I just wanted to have you brought in the virtual premises of RGIT, and our Kale sir and Department of Mechanical Engineering, Londekar sir, they've all organized this interaction, and this is the Alumni Speak series going on. Ajay Sharma, you probably know, he was senior. He had his talk last time. Today you spoke, and then the Lalita Naigam from USA and then Padma from Sweden. Both of them have consented. Lalita works with solar industry, and Padma is working with in Sweden with Volkswagen.
Oh, nice. Okay.
And so the 2010 batch is quite one of the most vibrant batch. Now, if someone asks me, do you remember your student? So what I recall is the batch of 2010. Because of the reason that this batch even had the maximum gate scorer also.
Yes.
You had your competitions done and so on and so many things. So this was great. I thank you for joining RGIT for this event, and I appreciate and congratulate all the efforts of Kare sir and Londekar sir, all the team members of our mechanical engineering, and thank you so much. Kale sir, over to you.
Yeah. Actually, your slide on that career chart, that was very impressive. And the explanation you gave and how to achieve your career goals, that must have been very beneficial for our students, those who are watching. And actually, we are going to keep this video on YouTube channel, RGIT channel. So many of the students probably they will visit afterwards and see that video. And that slide, I think I'll definitely suggest to our students, current students, to see the slide actually. That was really good.
Thank you. Thanks a lot.
And that is applicable for all. Actually, it is applicable for us, all for us also, for faculty, and so those who are young faculty.
Definitely. Yeah. Like I said, I mean, it has helped. That slide has helped myself a lot. So I hope it does.
Yes.
Hope my presentation was
your example. Yes.
Yes. So yeah. So I said, like, my own career has shifted a lot. So that slide has been quite a helpful when you think you are lost. So that's where you can reflect on those things and come back. So we are engineers. You need to do it methodologically. It's always like that.
Great.
Thank you.
I think over to you, Mangrulkar sir.
Yeah. Thank you for that. Thank you, Aniket. Hello.
Yep. Thank you. Thank you. Thanks, sir.
Thank you, Aniket. I hope all the participants are satisfied, happy, and optimistic with your answers. Now I hand over and request Professor Amol Mangrulkar to deliver the vote of thanks.
Thank you.
Over to Amol, sir.
Yeah. Thank you, Dr. Atul Londekar, our distinguished alumni and today's speaker, Mr. Aniket Chaudhary, and participants from all over the world. It deems a great honor to me to propose the vote of thanks to all who have helped us in making this event such a resounding success. Mr. Aniket has given excellent wide coverage for various career opportunities for all engineering streams. in the world of automobile engineering. Indeed, your words of experience and encouragement will inspire students to seek a career in the automobile sector. Finally, I want to give thanks to management of MCT's Rajiv Gandhi Institute of Technology, Honorable Principal Dr. Sanjay Bokade, Vice Principal Dr. Sanjay Deshmukh, our Head of the Department of Mechanical Engineering Dr. Rajesh Kale, all HODs, coordinator, technical team, all staff members, and all participants for gracing this event. We are delighted to announce our next webinar topic on Saturday, 4 July 2020 at 5 p.m. Our next speaker in the series is our alumnus of 1996 batch, Mr. Prafulla Dangat. He is a Vice President, Commercial and Technical at Reunidas. The link of the same will be shared to all registered participants on the Telegram app. Thanks to all and have a nice day and stay safe and be a part of our upcoming Alumni Speak series. Now, may I request technical team to end the webinar. Thank you all.
Thank you. Thank you, sir.
Thank you.